So what do we need to do now? So the idea is we need to set our reference sensitivity sets. So the idea is this. Let me explain the concept. Setting sensitivity means in the layman term is what is the minimum, the thinness defect that your units are set up. What is the thinnest indication or crack or notch or whatever that I can see at a particular gain position. So we've set our gain. So the final thing is to identify our reference notch. This is very critical. If you look at this calibration standard, this calibration block, there are three notches: 0.02 inch, 0.04 inch, and 0.08. So in metric system, 0.5, 1 mm, and 2 mm notch. So as you proceed this way, the notch is getting deeper. So the direction matters a lot. Like I said, if you are using this my palm, if you scan, this is the coil, it is perpendicular to this line. If I go, it will not give you as much high intensity in terms of impedance compared to when I go like this, because the coil is moving perpendicular to this line. So it creates a lot more impact compared to going with this line. So your direction matters. Now, if I put it on this notch and I balance, if I go this way, you see what came out. Now, if I go the opposite way, you see the opposite way gives, and it also affects the direction. You see, it's way longer and it's way sharper. Let me balance again. We'll try it second time. When I turn the direction, you see, it's shorter, but when I go the opposite way, so direction does matter. So now when we want to set the sensitivity, we want to see if the impedance curve that will be drawn will cross this. And I go through, since I'm using my 1 mm, if I go through my 1 mm, if you look at my 1 mm notch, it only ended here. I want my 1 mm notch to be able to cross this gate. If it crosses this gate, it has given me the sensitivity that I want. If this is 100%, 20, 40, 60, 80, this is already at 80. So if the impedance curve we are producing, if it crosses the gate, it means it's giving us the right sensitivity. If it does not cross the gate, so let's say it's already crossing, which means my sensitivity is very high. It means my sensitivity is very high, and you can even see the time based on how sharp it is. So what we'll do, we can start by reducing our preamplification first. Let's take it to 3. We balance again and check again. It's still very high. We can reduce it to 2 before we start working on something else. Still high, so we'll go to our general gain. So let's reduce our general gain substantially and try again. Still very high. Still very high, so we reduce further by 2 dB. Okay, so we're almost at the right still very high. Let's reduce our vertical gain a little. Okay, so we are the right. So we have set our sensitivity. So what it means is that if we are in the field and we get something that is any indication that is 1 meter deep, we should be able to see it just at. So any indication that does not give an impedance curve that crosses this gate, we don't have to concern ourselves with it. So we have set the sensitivity with a 1 mm notch. So that way your calibration is complete. You can do further verification by taking a scan. So I balance again, I take a scan with the 3 notches and confirm. This is the first notch, second notch. So if I search and I come to position and I scroll down, this is my 1 mm notch, which is even a little bit more. But we can still work with it like this. If we look at our 0.5 notch, just a little. So the idea is whatever indication that does not pass this gate, we will not consider it as a relevant indication.